So I can flip it, right? To do division goes to multiplication. So this is going to be 25 over 144 times 1 over 8. So this is my scratch work on the side, right? So my next line over here is going to be that this turned into, oh, I never multiplied across, sorry. 25 over, what's 144 times 8? 1,152? It's getting pretty nasty, isn't it? Okay, so 25 over 1,152 plus a half times 8/3. So I'm going to kind of save ourselves a little bit of time here. I'm going to go ahead and convert this division over to multiplication now. Right, so I'm flipping the second one over, right? And what does that become? Yeah, so I get 25 over 1152 plus, and you said that this, I heard 4/3, you're reducing, right? This 2 goes into 2 once, 2 goes into 8 4 times. So this is just going to become 4/3. We're almost done. That's where we are. So how do you add two fractions? You have to have a common denominator, or you use the shortcut. If you use a shortcut, your numbers are going to be huge, right? So did anyone do this one? Yeah? Did you have a common? Did you do the shortcut, or did you get a common?
I got a common.
You got a common? Is it this? Is this?
Yeah.
Does it go in there? Yeah.
That's the
So it goes in there. 6. Yeah, it goes in there. So this can be your common denominator, 1152. So you have to turn 3 into 1152. So you multiply it by what to do that? Just get on your calculator and do 1152 divided by 3. What is it? 3 what? 381? 4? 384. So you multiply 384 here, 384 there. That way this denominator will be the same as that one, and then you can combine them. This is a nasty problem. But it's testing a lot of different things here, isn't it? 25 over 1152 plus, okay, I need someone to give me that on their calculator. 1536 over 1152. And now that we're adding, we have the same denominators, we just add across. So 1561 over 1152. All right, that's a very good question. Yeah, I don't have time to do more. If you run into any issues, you want to come by, office hours, tutoring lab, call me, text me, I can help you. All right, let's see where we are on the schedule. We still have time. I'm just wondering. Yeah, we can do this next part. I think this next part's pretty straightforward for most students. It looks terrible, but it's not as bad as it looks. So we're talking about orders of operations with these things called polynomials. So you know how when we were solving these linear equations, we were combining x terms together? Like whenever we saw like 3x plus 4x, we would say that's 7x. And the reason you can do that is because they both have x to the first power. So this is like 3 apples plus 4 apples gives you 7 apples. Well, what we're going to be doing here is making sure we understand how to do operations on polynomials where we have letters, variables raised to different powers. So in order to add them together, they have to be the same letters raised to the same powers. And those are what we call like terms. So let me go through this first one. And I think once I do it, you'll kind of hopefully catch on. If I'm going to try and subtract these two, then I need to first get rid of these parentheses. So how can I get rid of the parentheses on this first one? I have to distribute something through, right? What do I distribute through this one? So what's out here in front? Positive 1. So nothing is really going to happen. Everything's going to just stay the same, isn't it? Just going to be 3a plus 2a squared plus 3a cubed. Now I have to remove the parentheses on the second one. What's going to be distributed through? This time a negative 1. So negative 1 is going to go through here. And when you pass a negative 1 through, it changes the signs of everything. So instead of a, we have minus a. Instead of plus 2a, we have minus 2a. Sorry, instead of plus 2a squared, we have minus 2a squared. And instead of minus 3a cubed, we have plus 3a cubed. That all makes sense to everyone? Now you can combine anything that has the same letter to the same power. So let me start with my a's. I have 3a's, take away an a, right? What's 3a take away a? Just 2a, right? Trying to get through these names. Sylvia?
Yes.
What's the next thing we can combine together here?
The 2a squared.
2a squared? Negative 2a squared. What would happen if you put those together? They cancel, so they're gone. We don't have any a squares now, right? They're just gone. All right. Sylvia, you want to finish it up? Okay, so
You just add the 3a
3a cubed.
and then add
Other one. So when we add those together, how many do we get?
the 6a.
6 of them, right? So 6a cubed. So plus 6a cubed. And that's it. That's how we combine polynomials together. We remove any parentheses, and then we collect like terms. Does that kind of ring a bell? All right, on number 2, do we have to worry about distributing anything through, really? On number 2, there's a 1 out here and a 1 out here, right? So when you drop the parentheses, everything just drops, and that's it, right? And then you'll combine. Maybe we can do it without writing too much down. How many a's will you have when you combine those together? 9a. Okay, that'll take care of those. How about a squareds?
1 and 3/5.
So you have to combine 2 of them, right? 2a squareds, and you have to take away 2/5 of them. So that means what you should do is do 2, take away 2/5. You have to figure out, right? Just like you did 3 plus 6 was 9, right? Here you have to do 2 take away 2/5, and that's how many a squareds you'll have. So you're back to what we did before. You have to get a common denominator, right? This is 2 over 1. Get a common denominator, put these together. Assuming you could do this, this should be 8/5. 8 over 5. I'm doing the shortcut. 2 times 5. 5 times 2 is 10. Take away 2, that's 8, and then divide by 1 times 5. Yay or nay? Okay. So how many a squareds do we have? 8/5. So I put plus 8/5 a squared. And then we have to put together the a cubes, right? So what numerical operation do I need to do to figure out how many a cubes I have? I have 3/5, right? And then from that I need to take away 3. So again, common denominator. All right. So I'll rewrite the 3 as 3 over 1, and I'm going to do the shortcut again. So let's see. Heidi? Where's Heidi? Do you know what I mean by shortcut? Or you just want to get a common denominator here?
When you do shortcut, you multiply 1
Here to here.
and then 5 times 3, right?
Yes, so 1 times 3 is 3, right? And then you put minus, and then you said the 5 times 3? 15, and then over 5 times 1 is 5. And then that will give you, what's that, negative 12/5? Okay, so this should be minus 12/5 a cubed. Okay, I think we're probably going to need to stop there. Number 3, you could do the same way, except that you have to distribute a negative through here first, right? So in the next 5 minutes, I'm going to have you sign in. Sorry. And I didn't get through all the sticks. But I'm going to share something with you that may appear on the test as a bonus question. So this is totally optional material. Hopefully I can cover it in the next 6 minutes. So sometimes I like to share kind of not useless information, but kind of useless. All right, so there's a story, famous story in mathematics about this kid who lived back in the late 1800s. His name was, I believe, Frederick Gauss, last name Gauss. And so the story goes that his father was an accountant. This is back in the late 1800s. And he used to sit in his dad's lap while his dad was doing the books, doing accounting. And that this kid Gauss could like add up the numbers in his head when he was very young. So everyone knew Gauss was gifted, but it wasn't until he got to like first grade that they knew something was very special. And so here's the story. Gauss goes to school, first grade, late 1800s. Teacher goes into class that day and asks the students to do the following problem. First grade, okay? So the first graders look at that and they tell the teacher what? What is that? 6, right? Okay. So the teacher said to them, all right, what's 1 plus 2 plus 3 plus 4? And they said 10. And then the teacher said, okay, what I'd like for you to do now is I'd like you to do this, and I'd like you to add up the first 100 numbers. No calculators, no cell phones, okay? So the story goes that the teacher was really just trying to give them some busy work that day, just trying to let the students sit there and do something while the teacher was, I guess, updating the Snapchat or something. I don't know, doing something, whatever they did back in the 1800s, right? So there they are, students are working away. Within a few minutes, Gauss, well, I should tell you that back in those days, they didn't write on paper in class. They wrote on like little chalkboards. They had little slate chalkboards. And so what they would do is when they were done with something, they would turn their slate over, put it on their desk, and they would sit with their arms folded because they had discipline and stuff back then, you know. So Gauss turns his little slate over, sits there, and the teacher walks up to him, turns his slate over, and Gauss has this written down. N times n plus 1 divided by 2. And the teacher looks at that, and let me explain what it is first, all right? This is a formula that will do that arithmetic for you. All you have to do is plug in n, and n is the last number you see. So if you want to do 1 plus 2 plus 3, then that's your n. Let's check it. If I use that formula for this n, what would I get? This would be 3, right? And then what? 3 plus 1 over 2. And let's see what that is. That's 3 times 4 over 2. 3 times 4 is 12. 12 over 2, that's 6, right? And that checks with this. If we did it for here, n would change to 4, wouldn't it? So this would be 4 times what? 4 plus 1 all over 2. And to go a little faster, this would be 20 over 2, which is 10. And that checks, right? Understand? So teacher turns over the slate, sees this, and asks Gauss where he learned that formula. Because that formula was already known, okay? It wasn't like Gauss came up with it. Teacher's like, where'd you get that from? And Gauss insisted, nobody showed me that formula. I just came up with it myself. Teacher didn't believe him, took him to the principal, he got into a bunch of trouble. So he had to explain to his teacher how he got it, all right? And I'm going to, in the next 2 minutes, explain it to you, all right? So here's what Gauss said. See if you can follow this or not, all right? Gauss said, hey, I'm going to try add up the first 100 numbers, right? So what would the last number be? Okay, what would the number before that be? Number before that. Okay, and then there's a bunch of stuff in between, right? Gauss said, I'm going to call this, I don't know what he called it, but I'm going to call it x, just to make it easy for us. Gauss said, you want me to find x, right? So then Gauss said, look, x, when you add things up, it doesn't matter what order you go in, right? Because addition, you can switch the order. So Gauss said, I'm going to write this backwards. 100 plus 99 plus 98 plus dot, 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 dot. What would the last number be if you turned it around? 1 plus 1 before that? 2 plus 3, right? And then Gauss, this was the amazing part. Gauss said, what I'm going to do is I'm going to add these two lines together. Okay, so what would x plus x be? 2 of them, right? So 2x's is equal to adding these two together. Now that may seem crazy to add these two together, but look at this. If I add straight down, what is that number? 101. What is this number? 99 plus 2. 101 again. What's this number? 101 again, right? Plus all the way down, these are 101s, aren't they? All the way to the very end. Agreed? Yes. How many of these are there? How many 101s are there? 100 of them, aren't there? So like when you write 5 plus 5 plus 5, a shorter way of writing that is 3 times 5, isn't it? So what's a shorter way of writing 101 added up 100 times? A 100 times 101, right? Isn't that what it is? So Gauss said, that's twice as much as I wanted, right? So I'm going to divide by 2. So he divides both sides by 2. And you get this, right? So the teacher wanted him to add up to 100, right? So here's 100. The next number is always going to be one more than that, right? Because you're always going to have, whatever your last number is, this one down here will always be one more than it, right? And so if you stop at n, right? If you stopped at n instead, then when you add down, these would be n plus 1s. Each one of them would be an n plus 1. N plus 1, n plus 1. How many of them would you have? You would have n of them. So you would have n plus 1s, but that would be twice as much as you want, so you divide by 2. Now if you follow that, how many of you kind of follow that, right? So this is what makes a genius, all right? Is that this is a first grader, and now that you see it, a lot of you are understanding it, but not many of us can actually make that like this sort of deduction. Now, he went on to do brilliant things in mathematics, as you might imagine. And so on a bonus question, what I might do is this. I might ask you to add up the first 3,251 numbers, right? And so nobody's going to sit there and punch away on their calculators. Maybe I'll make it even longer. There we go, I'll make it like 3 million. That way no one is going to even try it on their calculator, right? But if you just go into this formula, replace that with this number, and then add 1 to it, divide by 2, that's the answer. All right? Interesting? No? Gauss? Yeah, they had different standards in education back then, I think. Yeah. All right, everyone have a great day, right? We're done? I went over, I'm sorry. I apologize. Where's the sign-in sheet? Did I get around? Okay. Let me turn off the camera, and then I'll come over here and help you.